How's it going, Science 10s? What's going on? Um, Before we really do anything, what I want to do is I want to show you a little bit of a demonstration. Now, I can't show it to you in real life, but I can try and show it to you through the magic of video. So what I'm going to do is we're going to have some methanol, and I poured some methanol into like a big water jug that you're about to see here in a second. And what we're going to do is we're going to try and react that methanol with oxygen. And without really saying too much, I'm just going to go ahead and I'm going to go ahead and let the video speak for itself. So have fun and enjoy. Whoa! Did you see that? I don't know about you, but I thought that was pretty cool. That's called a whoosh jug experiment. Now, just to get a little bit of a better look at it, let's try that again, but in slow motion. Okay, did you catch that again in slow motion? Oh, I thought that was pretty cool. Pretty neat of me to be able to do that. Okay, so what did we make? Does anybody know? What did we make? So yeah, we reacted the methanol and the oxygen together, but what did we create? Well, I know that we definitely created a little bit of heat. Do you remember what kind of a reaction that's called? If heat exits a reaction, if you release heat to your surroundings? Oh, okay. Maybe you do, maybe you don't. That's okay. Anyways, let's get back at it. Let's start learning about some combustion reactions. So we're learning about some combustion reactions, and you can see a combustion reaction from a mile away, literally a mile away in real life, but you should be able to see a combustion reaction. You should be able to notice it because it's a hydrocarbon, or something that has carbons and hydrogens in it, and then it's reacting with oxygen to produce carbon dioxide gas and water vapor. What does that mean, vapor? Well, it just means a gas. It's water as a gas. So combustion reactions always involve the burning of a compound in the presence of oxygen. You need oxygen in order to burn something. Well, where does the oxygen come from? It comes from the air. I know you know that. I'm not trying to be patronizing, but I'm just trying to be a little bit theatrical. It will always produce carbon dioxide and water vapor. Combustion reactions are exothermic. Remember, that's when a reaction releases heat or energy, right? What's the opposite of an exothermic reaction? Yeah, you're right. An endothermic reaction. There we go. Okay. So when balancing combustion reactions, like we're going to do here in a second, balance the carbon first, then the hydrogen, then the oxygen. So this is the order that we're going to balance it in. And you could probably do this just kind of simply by yourself, but it's good to just be explicit about it. Okay, let's write down our first chemical reaction. We're going to do a word equation just because it allows us to go from the words to the formulas. So propane reacts with, you guessed it, oxygen in the air, and it will always produce carbon dioxide and water vapor. There we go. Now, when I say always, I mean not always. This is, you'll deal with in Chemistry 30, you'll deal with a situation where you don't make carbon dioxide and water vapor, but at least for the next couple of courses, for Science 10 and for Chemistry 20, yeah, you're only going to be making carbon dioxide and water vapor. Okay, let's turn this word equation into a chemical equation. And the way we do this is we take these words and turn them into chemical formulas. So we're going to take every single one of these and turn them into a chemical formula. So propane, what the heck is propane? Well, it's this thing. We just said it. C3H8, and it's a gas. You burn, maybe, you or your family members might burn propane when you barbecue something. So if you barbecue some asparagus, that's what I'm talking about. Or barbecuing a hamburger or some fish or some whatever, right? Some peppers. Okay, or hopefully I'm not making you hungry. So propane, that's the formula for propane. Oxygen, it's going to react with oxygen, which is O2 gas. It's going to make carbon dioxide gas and water vapor. Perfect. So let's go ahead and let's balance this chemical reaction. Now the way we balance it, remember, is by balancing the carbons, then the hydrogens, then the oxygens, right? The carbons, then hydrogens, then oxygens. Okay, let's try this. 3 carbons on the left side, so we need 3 carbons on the right side. Hydrogens, there's 8 hydrogens on here because there's some here and none here, so there's 8 in total. How do we make 8? Well, 4 groups of 2 should do it. Now, the oxygens are pretty complicated. Where do you see oxygens in the reactant side? I only see them in oxygen. Hopefully that's not a big surprise. But I see oxygen in both carbon dioxide and water. So we have to add up all of the oxygens in both of these compounds. Now, just take a second and just try and count up how many oxygens you see on the right-hand side. Did you guess 3? Well, unfortunately, that's wrong. Did you guess 7? That's also wrong. Okay, let's try this. There's 3 groups of 2, so there's 6 here. There's 4 groups of 1, so there's 4 here. So 6 and 4 make 10. So there's 10 total oxygens on the right-hand side. How do I react and have 10 oxygens over here? 5 groups of 2 should do it pretty nicely. So here is our balanced chemical reaction. For every 1 propane molecule, we need 5 molecules of oxygen, and we will produce 3 molecules of carbon dioxide as well as 4 molecules of water. Perfect. All right. Let's do another example. Hexane C6H14 is a component of gasoline. Write the reaction when hexane is burned. Okay, no problem. So we're going to take hexane and we're going to react it with oxygen, and we're going to produce the same thing we always do: carbon dioxide and water vapor. Perfect. So let's take these and turn them into formulas, right? That's all we're doing when we go from a word equation to a chemical equation. Hexane is right here. It's C6H14, and it's a liquid. We're going to react that with oxygen gas, and we're going to make carbon dioxide gas and water vapor. I almost put liquid. Okay, again, we balance this reaction. Carbons first, then hydrogens, then oxygens. 6 carbons, 6 carbons. 14 hydrogens. How do I make 14 out of groups of 2? With 7 groups of 2. Then we're going to take our oxygens. So 6 times 2 is 12, plus 7 times 1 is 7. That's going to give us 19 oxygens. How do we make 19 oxygens? We can't. If you run into this problem, we can't make 19 out of groups of 2. What can 2s make? 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. It cannot make 19. So if you run into this problem, cross out or erase the coefficients you already put. Go back to the first compound that you looked at, that hydrocarbon, and double it. Now that we've doubled it, how many carbons are there? 2 times 6 is 12 carbons. 2 times 14 is 28. How do I make 28? Well, 14 groups of 2 ought to do it. And now, because I doubled this, do you see how every other number is doubling? So now we don't have 12 oxygens anymore. We have 12 times 2 is 24 oxygens. We don't have 7 oxygens over here anymore. We've got 14. We don't have 19 total oxygens. We have 24 plus 14 is 38. So how do I make 38 oxygens over here? With 19. That number, right? That number that we couldn't get before, 19 behind the little squiggly black marks, that's the number that you're eventually going to get here. So here is our balanced chemical reaction. What's going on is we're taking 2 hexanes and reacting it with 19 oxygen molecules to make 12 carbon dioxide molecules and 14 water molecules. Perfect, no problem. Let's try another one. This is the last example that we're probably going to do, and then I'll let you do some more yourself. So we're going to take butane. All right, no problem. Butane. And it's burned in the air. Well, what is burning something in the air? What is in the air that we're reacting it with? Yeah, you got it. Yeah, we're reacting it with oxygen whenever we burn something. And we're going to make carbon dioxide and water vapor. So now let's go ahead and let's turn these words into formulas for our chemical equation. Butane, C4H10 as a gas. It's going to react with oxygen as a gas. And it's going to make carbon dioxide and water vapor. So let's go ahead and balance this. Remember, we always balance C, then H, then O. So 4 carbons, 4 carbons. 10 hydrogens. 5 times 2 is 10 hydrogens. Now let's add up all the oxygens on the right-hand side. 4 times 2 is 8. 5 times 1 is 5. 13. Can we make 13 out of groups of 2? No. Remember, let's go back and just cross off all of these coefficients and double the first thing you looked at. Double that hydrocarbon. So 2 times 4 is 8 carbons. 2 times 10 is 20. How do I make 20 out of groups of 2? With 10. You see how these numbers are doubling, right? We doubled this, so everything else is going to double. So now 8 times 2 is 16. 10 times 1 is 10. So the total instead of 13 is 26. How do we make 26 out of groups of 2? Well, we need 13 groups of 2. And we've got ourselves a balanced chemical reaction. Woo! Okay. So what I want you to do, this is pretty straightforward, or hopefully it's pretty straightforward, every single chemical reaction. Don't tell your parents that I did this. We're not doing decomposition. We're doing combustion reactions. Parents, if you're listening, I'm sorry. Okay, so we've got some balancing and some states of matter, right? So I want you to balance all the coefficients, CHO, and then put in the states of matter that are here. Just fill in all the states of matter, what they should be. So that should be pretty straightforward. You're going to get some pretty big numbers here, but okay, all right. I have faith in you. Made it. I did it again. Combustion reactions practice. Okay. So here, predict the products. Well, what are the products in a combustion reaction? I should hear a chorus of you guys telling me, yelling at your computers right now. Carbon dioxide and water vapor. Okay, so you're going to make carbon dioxide gas and water vapor gas, right? Every time you burn something, hydrocarbon plus oxygen is a combustion reaction. So go ahead and practice these. Practice these examples at the bottom too. I know it's a lot of work, but go ahead and practice them. And you're going to get some pretty big numbers for some of these, but I have faith that you can do it. Check the notes for the answer key for these notes. Check the notes that I'm posting online, and just try and make sure that you can do it. And let me know if you have any questions. Before I let you go, I'm going to let you watch another reaction here. This is another one I wish you could be here for. What we're going to do is we're going to take methane and we're going to react it with oxygen, and we're going to make carbon dioxide and water vapor. And I want you to just make sure you understand that this is an exothermic reaction, okay? Should be pretty easy, but it's also pretty cool. So go ahead, watch the rest of the video, have fun. It won't take very long, and let me know if you have any questions. Come see me in the office hours from 10:45 to 11:15 at the Google Meet if you have any questions. All right, have fun.